Most of the books on R will tell you that a matrix in R must be numeric, but that's not strictly true. You can have characters. Where do they come from? Why do we have them? Well, they come from matrix math. All of your multivariate functions, regression, multivariate regression type functions deal with matrices of parameter values. So it's important. So let's look at a matrix. So here we're going to use row bind. We're going to row bind this vector and this vector into a variable m. And what does that look like? It creates a matrix. The first vector, here was the first vector, 1, 4. Okay, that became the first row. And here is the second vector, 2, 2. That became the second row. But it also changed the structure. It put it in a matrix. And you know it's a matrix by looking at it because you see both the rows and the columns subscripted or indexed with a two-dimensional index. The first number is the row number, then you have a comma, then the second number is the column number. If it's blank, it means all the columns. So 2 comma blank means second row, all columns. Blank comma 1 means all rows, first column. So that's how we can index our matrix. Now you can perform a whole set of any sort of matrix function, multiplication, inverse, transform. You can do them all in R, and at some point we'll look at those. Okay, again, they're indexed with the double subscripts. You can extract rows and or columns using the indexes. Okay, let's go on and look at lists. Okay, lists are very useful. Lists are heterogeneous. They're like the C struct if you're into programming in C or C++. Here we're going to create a list. And it's going to have two components. The first component is going to be named U, and it's going to have a value of a vector with one element 2. Second component is going to be named V. It's going to have one element. It's a vector of the string ABC. So let's do this. So we do this and take a look at it. Here's our list. Note, in this case, the components are named because we named them when we created it. Instead of showing me the double subscript like we saw in this previous example here for string split, instead of seeing this is the component, has a name because we gave it one. You can name either the rows or the columns or the components in any structure in R. A vector, you can name each element in a vector. A matrix, you can give the rows names, you can give the columns names. A list, you can give same thing. You can give the components names. A data frame, same thing. You can give rows, columns names. If you don't, they will default to these indexes that every computer knows and loves. Okay, but you have a choice, which is handy. Okay, so here we have names for our components. Note it's showing a $sign and the name. The $sign has no intrinsic meaning. It's an operator, which in R means the name of the component. Okay, so if we want to see the value of a component, since the list is named X, if we want to see the value of the component U, we could address it saying X $U. That says, show me the value of the youth component in list X. Or I could say X $V. Show me the value of the V component in list X. Okay, we did hist already. Okay, well, yeah, we did hist already. We saw what that did. Here it is. But did you know that actually when you run this function, it draws something. It also creates an object, which creates this plot. It creates a structure. It outputs, this is a function, and it outputs an object. It returns something, which is manifest for us in this plot. But you can capture it. If I run that histogram function and I assign it to a variable, what happens? Let's try that. Well, we do that. It redraws the plot. But what does NH look like? How do we know? Let's look. We'll say print, or just HN, if we say, show us what the object looks like. So there it is. Okay, let's take a look. So this is what actually was created from that histogram function. Note what it is. It's a list. It's a rather complicated list that has all of these components. These components are characteristics of this graph. And this thing is stored. We can store it. We stored it in a variable. And I don't even know what all these are the frequencies in the bins. These are the breaks. These define the breaks. I don't know what all this stuff is, but even when you create a plot, you run a function, it outputs an object, and most functions in R output a list. Why? Because a list can handle complex components. Note all of these components describing this graph. They're different sizes, they're different types. Some are integers, some are real numbers, some are strings, some are true false. You can't put that in any other structure. You can't store this information in a vector or a matrix. A list is your only choice. So the function outputs a list. Well, is that good? Yeah, it's good. Is it bad? It can be. Not all functions will operate on a list. Some functions will, some functions won't. So that's where we start getting into complications. Okay, let's... okay, so we have that. Another way that's easier to see the nature of an object is structure, str. Let's do that. If we execute str against that hn object, make the window a little bigger so it doesn't wrap. Note what we get. It's showing us a very concise, the name of each component, the type of each component, the number of elements, some of the values of the elements. str is your friend. str is a command that you will use often that shows you the nature of the object, of the structure you're dealing with. Okay, the next structure that's very important, data frames. A data frame is the data structure of choice for data sets. Whenever you deal with a data set in R, think spreadsheet, a spreadsheet of data, which you will do all the time with any sort of statistical analysis, SAS, SPSS, R. You're running them on data sets, which in R are implemented as data frames. It's a mix between a matrix and a list. A data frame is it's two-dimensional, but unlike a matrix, each column, a matrix I did not mention this, and I should have. A matrix, all of the elements must be the same type in a matrix. In a matrix, which is two-dimensional, rows and columns, you can have a numeric matrix or a character matrix, but everything must be the same type. A data frame, each column must be homogeneous, but you can have different data types in different columns, just like in your spreadsheet. One column might be numeric, another column might be date, another column might be true, false. Same thing. Let's look at this. So here we're going to create a data frame using the data frame function. And it's going to, first of all, we're going to create a list. The list is going to have two components. Let's do this incrementally. In fact, we could even break it down further. We're creating a vector called kids. So here's kids. We've got kids now up here in our window right here. Notice when I change the graphics window, we get this funny stuff. We'll talk about that more later. It only happens in RStudio. Okay, here's kids. Okay. Here we're going to create another vector. It's called ages. Create that. Here's ages. Now we're going to put these in a list. So we create our list. Notice we're going from the inside out. So now we have a list. It shows up here. No, it doesn't, because we didn't preserve it. Here it is down here. Now we're going to make it a data frame, and we're going to assign it to D. See D up here. Note with data frames, you can double click on them in the workspace, and they show up in their own tab looking like a spreadsheet. Very handy. You can just simply double click and you can see what it looks like. Okay, if we wanted to see just the ages column, we would refer to it by the name of the data set, $, name of the column, just like a list, because it is a list actually. A data frame is a type of list. So we do that, it just lists the ages. Okay, we'll come back to each of these structures. 4 important structures: vectors, matrix, matrices, data frames, lists. There are other structures, but those are the most critical: vectors, matrices, data frames, lists. You really need to get grounded. You need to understand what the differences, what they are, and you will, in order to be effective at doing anything in R, especially programming. Okay, R is object-oriented. We have classes. Everything is an object. An object is belongs to a class, which gives it properties, gives it attributes, and often methods, behaviors. Classes are not the same thing as a data type. Classes are more complex actually than structures. Okay, R is kind of weird because R came out of the S language and the S+ language, and the S+ language was it was S version 3 actually is what it was, and there are classes just like in Java, C++. You have classes. You had libraries of classes in S version 3 that were adopted by R. And so they're called S3 classes. That's what they're called. But R can also, the newer versions of R, you can develop S4 classes. And we'll do this in this class, in this course. We'll look at the differences between S3 classes and S4 classes. They're different beings entirely.